First of all, we will spend some time on some non-TensorFlow stuff, right? So we will prepare our data, that is quickly generate our data. Okay, so this is a script that we'll be working with. Now, import TensorFlow as TF. The import statement is how you import your libraries on TensorFlow. We'll definitely need numpy, which is a numerical computing tool in Python. We will need some math. We'll need some plotting, and we'll need some animation to go along with it, as we will discover. So these are the libraries that we will require, right? And what we said was we will generate some data on house prices. We are not going to use any industry level data. We are just going to generate our own so that we can quickly get started. So I'm saying we are going to generate 160 house price and house size data. Okay, I'm going to set the seed here so that we come up with the same data every time. So the house size is the first variable that we are going to generate. Okay, so I'm saying here between 1000 and 3500, give me 160 values of house size. Okay, and again for house price, I'm just going to multiply the corresponding house size by 100 and then add a random number to it so that we have some variance. Okay, now I'm sure as you step through some code, once you get this script, you will understand everything in detail, but I just want you to understand things on a very high level. So we are building a strategy on generating some data so that we can get started. That's all we are doing, right? So we generate some house size data randomly, generate some house price data randomly, and then we go forward with plotting the data using matplotlib here so that we can see our relationship, so that we can see our generated data. Okay, so I'm going to execute this snippet of code, and this is what the plot looks like. So on the x-axis, I have the house size. On the y-axis, I have the house price, and see how they develop a very linear relationship like this. So as the house size increases, the house price increases with it, right? So there's a very clear relationship between these two guys, which marks that we can come up with a pretty strong predictive algorithm for solving this problem. The typical predictive algorithm that is used is linear regression, which basically, as of this point, has nothing to do with deep learning. So right now we are not doing deep learning. We're just stepping through some normal examples. Okay, we're going to normalize this data because that's what we do. So you look at the unit of the price, right? It's in millions. You look at the size, it's in square feet. Two different units. One is millions in money, the other is square feet in area. Not very compatible kind of data to work with. So this normalization technique, what this does is it subtracts the mean of one particular column with each of those values and divides it by the standard deviation. Again, this is a way to normalize our data. Basic statistics knowledge. Okay, so I'm just going to execute that, and then what I'm going to do is I'm going to define my number of training examples as 70%. So done. Here what I'm doing is, let's say we have some data here. Let's say we have some data here on house prices. Typically what we do is we split the data like this. So 70% here and 30% there. The whole of the data, we split it like this, 70-30. We are going to train here. That is, we are going to build our algorithm here. And then we are going to test it out over here so that we make sure that the algorithms works just fine. Okay, so we are doing that basically. We are splitting our data 70%, and we are defining our training data like this. So house size will be the 70% of the house size data, and then the price training examples will be 70% of the house price data. Okay, so the house size and house price, two of the variables. Done. Now, as already stated before, we are going to normalize our data so that we bring them to the same unit. We are going to define our test data just like we defined our training data. Done. And then we are going to normalize our test data as well. Okay. So with that being done, we've actually covered part 1 of this whole thing, right? So preparation of the data is complete. What did we do? We generated some random 160 examples, right? We generated some random 160 examples. We normalized them. We split them into train and test set. So preparation of the data done.